So good morning to all the people in this room. I'm excited that you decided to start the morning with attending this presentation, probably even sacrificing some additional sleep time, just like I did. And as we all here, let us start. So this is a presentation about the Android malware called FakeCalls, which is targeting South Korean financial customers and can be described as a remote access trojan on the surface. But what makes this malware special is the number of the details that is present inside. And modus operandi of FakeCalls is voice phishing, so it helps to conduct voice phishing attacks to its operators. And this is all what we will discuss in this talk. So before we start, let me introduce the researchers. And unfortunately, Bogdan was not able to make it to London, so I'm responsible for speaking on his behalf as well. And my name is Raman. We are both malware researchers in Checkpoint. This talk is divided into 4 chapters. We start with an overview of voice phishing in South Korea and take a look at the state of affairs of this sphere. Then we make an overview of FakeCalls malware from the high-level perspective. And the third and the fourth chapters are dedicated to the technical details and constitute the nitty-gritty of this presentation. In the end, we summarize everything that we have just discussed. So let us start with an overview of voice phishing in South Korea. And the state of affairs was so severe that it even drew the attention of South Korean government. And they published the report on their website, stating that the number of victims grew by 100% in the span of 5 years from 2016 to 2020. And number of victims for this period constituted 170,000. Financial losses in the same period increased by 350%. And in 2020, they constituted approximately $600 million. And even despite the fact that we don't have data available for later dates, we see that these numbers are pretty descriptive on their own, and they explain why the malware operators of FakeCalls chose this sphere, not out of the black, but because of historical records. So it's a pretty profitable sphere to operate in. And now, let us take a look at how voice phishing attacks are conducted in the case of FakeCalls. So it all starts with the malware application imitating a legitimate financial application from some financial institution. And what we find inside are fake loan offers with lower interest rates as compared to the legitimate offers from financial institutions. And upon applying for this offer, malware operators get a signal that they can proceed with this attack and begin the second stage. Now the interaction with the application is finished, and what the users or victims of FakeCalls receive is a phone call from an unknown number. But what they are shown in the reality is a phone number of some legitimate financial institution because it is being replaced by FakeCalls, so that the victims get an illusion of interacting with a real financial institution and a real financial employee. And the whole idea of this stage is to get the victim to confirm his or her credit card data, hoping to get a loan. And when this data is revealed, it means a reward for malware operators. And now, as we have taken a look at the voice phishing overview, let us take a look at FakeCalls from the high-level perspective. What we saw in this case is that the malware is spread via phishing sites, and it says low profile according to our telemetry. And we believe it is done on purpose to not draw the additional and unwanted attention to this malware. As we have already stated, it targets South Korean financial customers and can be described as a remote access trojan with many capabilities. One sample corresponds to one mimicked application, and when the user is interested in a particular application from one financial institution, this is what FakeCalls pretends to be. Inside, we found unique anti-analysis techniques, and when we say unique, we really mean unique because we have not observed any of these techniques used in any of other analyzed Android malware samples. And capabilities to monitor still and stream include, but are not limited to, basically every piece of sensitive data that can be present on the victim's device, including location, audio, data from the cameras, both frontal and back, and so on. So we believe there is a high damage potential for the victims in this case, not only because of anti-detection measures and capabilities for stealing, but also because of that malware decided to attack Users of more than 20 trusted and solid institutions, and while we can't reveal the names of these institutions, due to the restrictions of our company's policy, we can say that they are trusted and solid indeed because they are given high grades by world-respected evaluators. Some of them have trillions of Korean won revenue, which is equal to hundreds of millions of dollars. And many of them are among largest financial organizations in South Korea. And now we are ready to speak about the nitty-gritty of this presentation, about the used evasion techniques, and dig deeper into the technical details. Before we start the discussion of evasion techniques, we will speak about the tools we typically use for the analysis. JEP-Pro is a jack of all trades, very powerful debugger and disassembler, but sometimes we do not need its power and switch to JADX, which is a bytecode to Java decompiler, and it's pretty convenient in code exploration and getting the references to various pieces of data. APK tool is a universal Swiss Army knife, which can be used in automated analysis to make various operations with the analyzed application. And to our surprise, none of these tools was able to correctly proceed the analyzed sample of FakeCalls, and this is an example of how JEP-Pro failed to load it. And now we state it as a matter of fact, like we tried to analyze the application and we did nothing, but at the moment it was pretty scary because it's not something that you encounter on a daily basis. And you wonder, maybe something wrong with the application, maybe some broken bytes are encountered inside, or maybe the update just made up something with an analysis tool. But then when the initial shock has passed, we decided to investigate what was happening. And here is a fast forward to the results we got. APK stands for the analyzed Android application, and in its essence, it's just a usual zip archive, which can be opened and analyzed with the usual zip archive tools we usually use. But in this case, we couldn't do it because of the applied evasion technique. And this is where we needed to apply a first fix. And after this fix, we were able to take a look at the contents of the archive and check for the key details present there. So the manifest is the cornerstone in the Android malware analysis because it contains the permissions that are used by the application, and it shows the starting code execution, where the code execution starts. But in this case, we could not even decode it, so we could not launch the analysis. And this is where the second group of evasions was encountered, and we applied fixes to them. After this point, we were able to load the application into JEP-Pro and JADX, but APK tool still failed, and that meant we couldn't apply the automated analysis to the bunch of this application. So we needed to apply yet another fix, and we fixed the long file names. We will speak about these evasions just in a few slides. And this concluded all the fixes that we have made to this application. And despite the fact that there are 3 groups of evasions, there are 6 evasions encountered in total because multiple groups contain different evasion techniques. So let us start with the first one, and it's called multi-disk evasion, which was, the screen that assisted us in understanding what we had to fix was the one that was produced by JEP-Pro. So usually when we analyze APKs, they are present as a single file archives. But in this case, we encountered a multi-file one, which didn't make sense because we had only one file, no multiple files. And so we started to search what was the reason and discovered that the values that are responsible for saying if the archive is single one or multi-file one are stored in the end of central directory structures. Namely, these values were of interest to us, and in most of the analyzed APKs, they are equal to 0 because there is only one disk present and its number is 0. But in this case, when we analyzed the values present in these fields, we encountered some high ones, which didn't make any sense at all. So we had to set them to 0, because it said that the file should be a single file archive and proceed from this point. And upon comparison of FakeCalls with other applications, we encountered some discrepancies in yet 2 other fields. which corresponds to the number of files in the archive. But as you remember, we could not open the archive and to check the files inside because the evasion was not still fixed. So we had to blindly shot and hopefully get some result out of it. And what we knew for sure that these values must be equal, but we had two different values in them. So we decided to apply several fixes, and we empirically stated that one of these values was the correct one and was equal to the number of files in the archive, which we confirmed after the fix was applied. So the summary of multi-disk fix is that we fixed 3 values, set 2 of them to zeros, and the third one was set to match the number of files in the archive. That allowed us to proceed with the analysis and to get a look at the next group evasions, which was present in the Android manifest. And what we encountered here was that wrong magic value was encountered at the beginning, and the value ending with 0 was present, but it was expected either a value of ending with 1 or with 3. At this point, we could just blindly change these values to any of the expected ones and proceed from now on, but we decided to investigate a bit deeper and understand the origins of these values. And what we encountered was the APK tool source code, or to be precise, an issue opened 4 years ago when APK tool was unable to decode Android manifest. And it was because the value encountered there was ending with 1, but the description of the issue says that the correct value to be present here is the one ending with 3. So we concluded that according to all the standards, and not to make any crutches, we have to set this magic value to the one ending with 3. So we fixed this magic value, but yet another exception was thrown. This time it was connected with an unexpected start of the string inside one of the fields in the Android manifest structure. So we went on and checked what was happening and discovered the array of string offsets. And when we took a look inside this array, we found that all these values were aligned between each other, except for the last one, which was interpreting the data in a wrong way. Because what we see here is that the string is treated as an offset value, but it shouldn't be the case. And at this point, we had different possible solutions for this issue. We could change the value to something meaningful, or we could just reduce the number of elements in this array so that this value is not interpreted in the wrong way. And this is what we did because it seemed easier to us. And the value responsible for the number of elements in this array is called sc string count. So we just decreased it by 1, understood that everything was fine, and yet it was some kind of a bittersweet victory because yet we fixed this exception, another one occurs. But this is the last one in this group, so hopefully you'll not get bored at this point because we're almost at the end of the journey with the evasions. And the third evasion in the Android manifest group was connected with the negative array size exception. It meant that when trying to allocate the array, and we have a precise references to the string in the code where this exception occurred, we encountered some very high value which was interpreted as a negative one. And by looking at the code, we see that exception occurs in the string where the array is allocated, and just above the array size is calculated. And the value is read directly from the structure. And when we go to this structure and check this value, we see some very high number inside, which doesn't make sense at all. And here is why. So what we see here is that no styles are present inside the manifest, and yet style pull offset variable is set to some very high value, which doesn't make sense at all, because if no styles are present inside the Android manifest, then why to have style pull offset? So it's our safe bet to set this variable to 0, and luckily it fixes all the evasions encountered in the Android manifest, and here is the summary. So we changed the magic number, and also we changed 2 values, one to reduce the number of elements in the array, and another one to nullify the style pull offset. Now we are left with the last evasion, and this is connected with files with passes of more than the default number of characters that is expected for Android system. It happens because of the nested structure of how these files reside inside the assets. And interestingly enough, the main payload, yet another APK that is responsible for main functions, does not have anything to deal with this long file path madness because it's stored via a normal path. And actually, at this point, we had a suspicion that these long file names had nothing to deal with the internal logic of the application, so we could delete them safely. But to confirm our assumption, we went to the bytecode analysis and searched for calls to asset manager open functions and checked all the references to this function, and then analyzed all the arguments that were passed to it. And what we discovered was that no long file names were encountered, and only these short normal paths that were connected with the main payload APK were used. So it was a safe assumption to delete the files. And at this point, finally, we were able to mitigate all the evasions and load the sample into all of the analysis tools that we use. And this is the example of how the sample was successfully loaded to JEP Pro. So now we were able to take a look at the functionality of the main payload, and we will not go through all the functionality that we encountered, but we will speak about some key points that we find the most appealing and the most unique to the world of Android malware. What we encountered was that both frontal and back cameras can be streamed, but you know that already. But the most interesting point was that it was a dedicated server that accepted the incoming data from these cameras. And usually, when we analyze malware under Android or Windows, we see that there is one command and control server that accepts all kinds of incoming data. But in this case, in addition to this command and control server, we found a dedicated one to accept the data from cameras. So speaking about network communication, instead of directly contacting command and control server, FakeCalls makes proxy requests to a web server, which can be either a Google Drive or some kind of alternative server, which are called drop-dead resolvers. And what the malware expects to find in the cloud is a file name or the contents that is, of course, encrypted. And upon decryption of either the file name or its contents, it gets the list of real CNC servers. And the logic of interaction with these servers is a bit different. So in the case of Google Drive, malware is looking for a file name that is, of course, encrypted. And then with the help of AES, it decrypts the file name and gets the list of the servers. And when a non-Google Drive server is used, the malware is looking for the contents of this file. And in this case, we see 3 different pieces of information. And the decryption algorithm is pretty simple in this case. It boils down to just a simple XOR. And after the decryption, we get the following 3 pieces of data: command and control server, a dedicated one for streamed videos, and a new drop-dead resolver if the malware wants to update its configuration further. In this case, these values were resolved to the following ones. And so we are ready to conclude everything that we have just discussed. So what we see here is that the malware operators chose a very profitable market to operate in, according to the historical data from the South Korean government. And it chose more than 20 financial institutions in South Korea to be mimicked, or to be more precise, the applications issued by these institutions. And the organizations are chosen among the largest ones in the industry. With multiple anti-analysis techniques and stealing capabilities, we believe there is a high damage potential for the victims. And even despite the fact we cannot evaluate this damage, we think it's pretty high. And in case you're interested in exploring further details about this research, you're welcome to check these links. And you can either photo them or just check the copy of this presentation that will be uploaded to the Virus Bulletin website. And in case you can come up with or you want to come up with some questions, please do not hesitate to contact either Bohtan or me via the emails, and thank you for the attention.